All right, so the rest of the twin, 14, a town called Smallville, with population 3,500, is slowly shrinking, which means that we're going to use our formula for decay. Amount after time passes, the principal times 1 minus r to the t. And because of the way this one talks about every decade, we're going to have to use what I call time period, or just TP. So 9%, 0.09. The amount after time passes is the principal of 3,500. And again, I say this every video. Don't mute me. Like, just listen to the words that are coming out of my mouth and truly listen. And so that's what it looks like. I keep saying this, but some of y'all just don't believe me. I judge you pretty hardcore when you don't figure out what 1 minus 0.09 is. I really do. You're just being lazy. Anyways, there is a model that describes the population of this town every decade. I also mentioned the word decay there again. Convert your decade model into a yearly model. So this has been talked about. This is based off the idea of AB to the X. Actually, that's not the best one to do it. The best one to do it is X to the A to the B is X to the AB. So you'll notice that I took part of the exponent and I shifted it inside, didn't I? Like it went inside the parentheses. So when I look at t over 10, I see 1 over 10 times t. So I'm going to focus on this piece right here. I'm going to focus on 0.91. I'm going to pull the 10th in. And if I'll just push some buttons in a TI-84, which a couple of y'all are not doing, like you need to push the buttons. You're just being lazy and you're leaving it 0.91 to the 1/10. By the way, that is the 10th root if you forgot, which you probably did because exponents and kids don't mix. 0.9906. And now your equation accepts years. All right, use your answer from part 2 to determine the yearly decay rate. So let me line this up with the original formula. We call this the decay factor. And just notice how these two line up. 1 minus r lines up with 0.9906 because we're after the rate, right? So we have rate right there. We just do a lineup process. You move your 0.9906 over, you move your r over. 1 minus 0.9906 is r. And then you do some subtraction. You know, if you got to push buttons in a calculator, so be it. But I feel like that should be 0.094. It's 0094. Or 0.94% per year. So there's that one. And part 4, when will Smallville be down to just 2 people? So go back and use your model from 1, which was finished right here. Here's your model. And I want 2 people. That's going to go there. So it's 2 equals 3,500. These are questions that kids can do. They're not hard questions. They're really not. Well, I haven't even taught you how to do these by hand yet. I mean, that is coming. All right, let's go to y equals. Clear it out. We got a 2 there for y1, 3,500. Next week, we're going to be doing a lot of things that we've been using technology to do with by hand. So next week is going to be getting a little tougher. Anyways, I did a Zoom 6 because that's what I trained you to do. And I see my 2 people right here, so that's good. I just need to look into the future as soon as my calculator's done working. I notice some of y'all don't realize that your calculator is still working because you don't pay attention. There's a little circle there. I'm going to go 500 years. Actually, I won't even have to go 500 years in the future. It's losing 10% a year. I'm going to go 200 years in the future. I feel like that'll be enough time. But it may not be. I was wrong. Maybe. Still working. Oh, nope. I guess I will try 500. By the way, when you see me do an adjustment on a twin, it kind of tells you maybe how you should be adjusting on the test. I don't know if you ever thought about that. Probably not. You want everything to be super easy. You don't want to put in the effort. And you've got to learn that to actually truly learn, you have to put in effort. So this is a 500 look into the future. I still didn't see anything, which makes me think I have a typo somewhere. But I don't, do I? All right, 1,000 years. I don't know why, but this is surprising me. Took me 3 tries there to figure this one out. There it is. I'm going to copy down this whole decimal, 791.78425. 791.78425 years. Now, I will offer a bonus if you can do this in to the nearest year, day, hour, minute, second. So I know it's 791 years, 791 whole years there, right? And take that decimal point, 78425, and I'm going to multiply it by 365 to get the days. 286 whole days. Here I have 0.25125 of a day. All right. Well, I know there's 24 hours in a day, so let's multiply by 24. 6 hours. I got my 0.03 there. That represents an hour. If I multiply it by 60, I get minutes. 1 minute. Then I got that 0.8 of a minute, but if I multiply that by 60, I get seconds. 48 seconds. And Smallville will have exactly 2 people. And again, I will offer that as a bonus. All right, this is something that y'all did not like Tuesday, was the complete expansions. And one of the issues some kids had is they would view 2x as one thing, when it's not, it's actually 2 things. When I look at this logarithm, I see 1, 2, 3, 4, 5 pieces, all right? And I need you to remember things like this. If an argument is in the numerator, it is a positive log. If an argument is in the denominator, it is a negative log. Like you need that's how you do these things. And I know this is weird and funny because logarithms are just weird and funny. They'll start making more sense. I mean, we've still got at least a week and a half of logs left to talk about. So anyways, I counted things earlier, and again, I saw 5 distinct things that were in that logarithm. And this is not for somebody who's brand new at this, write an answer and be done with it. I mean, this is a multi-step process. You got a log base 4 of a 2, plus you've got a log base 4, because they're all bases 4s. A couple of y'all decided that bases weren't important of x, plus a log base 4 of y squared. Now I'm into the denominator, minus a log base 4 of 3 minus a log base 4 of z to the 5th. Now I talk about seeing if a log can be evaluated. If it can be a nice number, evaluate it. This guy right here says, what power of 4 is 2? You see, when I read a logarithm, I read them. I read them like that every single time. Well, I know that the square root of 4 is 2, and I know that the square root is 1/2. This is 1/2. Also, other things I could do is I could use my change of base. ln4 over ln2. Oops, I guess I said that backwards. It was ln2 over ln4, wasn't it? Because 2 was up top, 4 was in the bottom. 0.5. You see, these things are evaluatable. And it's a nice number. That's the big thing. It's nice. It's not a decimal. If you look at this one's what power of 4 creates 3, which, so we do ln3, change of base formula, kids, divided by ln4. And you don't want to write this on a piece of paper because it's an irrational number. It never stops repeating decimal. It doesn't stop at that 4 at the very end. It keeps going. So anyways, so plus log base 4 of x. We need to move our exponents out front. This comes from log of a to the r is r log a. So plus 2 log bases of 4 of y, it's a bad looking y, minus log base 4 of 3 minus 5 log base 4s of z. All right, here we have the opposite. Now that was an expansion. We took one logarithm and we made it into many. This is a condensing. We take many logs and make one. And this text over here, which you should memorize, and you should write, is the exact thing you need. If you see a logarithm that's positive, the argument's in the numerator. If you see a logarithm that's negative, the argument's in the denominator. And, you know, the last thing I did up here was I moved exponents out front. So it's actually going to be the very first thing that I do here. There's a 2, goes out front. Ta-da! So just make this 2 ln's of x. So let's see what we get. We got an ln, it's a singular ln, base e, that doesn't matter though. There's going to be a 2x in there, and then there's going to be an x squared, and the things up top get attached through multiplication. I don't know why I did that. Like I shouldn't have used that one. Brain fart. It's this 3 that's got to be moved. That one's fine. Apparently I was looking at something else. Here we have a 3. Now notice I'm leaving the negativity where it's at. I'm just putting a 3 there. So y cubed in the denominator, and then z plus 2 in the denominator, because these logarithms were negative. All right? So this should be cleaned up. 2x times x squared is 2x cubed. And the bottom is going to be y cubed z plus 2. And that's a complete condensation. You are condensing that logarithm. I think there's only 3 more left. We have a solve. This was Wednesday's content. The idea here is if you have a logarithm base b of some x, it equals a logarithm of the same base, and there's only a log on each side, of some y, then x is y. It's an if-then idea. So I know that 4x minus 7 must equal x plus 5. I can basically just, since the logs are the same, I can basically just ignore them. All right, I do basic algebra. X is on one side, numbers on the other. 4x minus x is 3x, and 5 plus 7 is 12. And then I divide out my 3, and my x value is 4. Now, does this work? Well, if you put a 4 here, 4 times 4 minus 7 is 9. 4 plus 5 is 9. It actually says log base 5 of 9 is equal to log base 5 of 9. So yes, it does work. 18, solve with the assistance of technology. So I'll have on your test a place for you to put y1, y2, okay? You're going to have to use change of base. And again, you should probably write this to help you memorize it. A logarithm, base b argument a, can be the ln of a over the ln of b, or it can be the log of a over the log of b. And then there's the chosen base idea, which just doesn't do us a whole lot of good in Algebra 2. It's more for more advanced classes, maybe a calculus class. The change of base technique makes a lot of sense if you grew up in the 60s and 70s, but not so much today. All right, so anyways, I'm going to have to rewrite this guy. So this is my a, and this is my b, and this is just a number. All right, it's not part of the logarithm. And I like ln, so I'm going to use ln's. A for above, 3x minus 1 is above. B for below, ln of 3 is below, and then plus 2. That's what I put in y1. y2, this is my a, this is my b. ln of x plus 3, a for above, over ln of 5, b for below, and then minus 5. And these are my y1s and y2s, all right? So now I'm in a, and by the way, I'm going to say this because somebody's like, ha ha, Milbrath, I figured something out. Good for you. There is a way in the calculator you don't have to use change of base. I just ain't going to show you because I'm not supposed to. I've literally had college professors ask us to not teach all the shortcuts in the calculator. So I'm not going to do it. Because for one, I think you should understand change of base. And two, I really think you ought to start using that brain of yours. You're not given a brain to be brain dead. Like you can do 100 million calculations per second. That is the capability of the human mind. All right. They can't all be about social issues or drama. Like just do what you're supposed to do. Anyways, moving forward, I'm on a second one. ln x plus 3. Sitting pretty over an ln of 5. And you know, a lot of kids, they don't type things incorrectly in the calculator. What they'll do is they'll, and I'll show you, but I'm not going to do it. They will put that plus 2 right there. And that's going to be wrong because then it's going to get divided by the natural log of 3. It's a very, very common mistake. I don't know why it's done. I just know they do it. Anywho, Zoom 6. If you read the text on this problem, I'm telling you, it looks like there's not going to be an answer, but there is because a calculator cannot draw a logarithm correctly. It can't do it. But there's an answer. So second trace 5, and you're going to have to push that right cursor button a few times until you see that thing show up. And when it shows up, you get to press enter, and it'll jump down to red, press enter, and then press enter for a guess. And even though it didn't look like there was an intersection, there was. It was 0.3337. About 3.337. That's going to be one of the easier questions on the whole quiz. You should probably do it first. And 19. So this is, I think, between all the little daily quizzes and whatnot, this is probably the 5th time that we've had the buying a car example. And that doesn't include any practice in class, okay? This is just me formally assessing it, see if you can do it. You are purchasing your first car. To purchase a car, you'll need to borrow $25,000. The terms of your loan are 5.9% interest compounded monthly for 5 years. Your formula is going to be the formula for compound interest. If you're wondering why I use that one, it's called the compound interest formula. And the amount of time passes the principal times 1 plus the R over N rooftopped to the NT. So let's plug some crap in. Principal, 0.059 is my R. Monthly, N is 12. T is 5. So the amount in 5 years, that's how we read this. This is read as the amount in 5 years. Not read ace of 5. Amount in 5 years is the principal of 25,000 times 1 plus 0.059. Sitting pretty over 12. And the exponent is n times t. A couple of you guys have been doing division. 12 times 5. And if you don't know what 12 times 5 is, God bless your little soul. Jesus does love you. Hopefully he's not as sarcastic as I am, because believe me, I love you too. I just can't be too nice to you, otherwise you'd never learn. So, again, if I don't know what 5 times 12 is, the calculator will not judge you. It's not me. I'm judgy. Just type it in as it's written. So, and pay attention to this. Like, I need you to understand this. There is a cost of borrowing money. And in this case, if you look at the difference between the two numbers, it cost you $8,500 to borrow money, didn't it? In a perfect world, you avoid borrowing. But you don't live in a perfect world. You're going to need to borrow. Just be cautious of what borrowing costs you. You are going to spend roughly a third of the value of this car paying a loan back. So anyways, $33,553. And we got some pennies. 90 cents. Look how that rounds. 0.896. 90 cents. All right, determine your monthly payment. Now, this was a 3-year loan. So if I'm talking about months, there's 12 months per year. Hopefully some of y'all have figured that out, because I know there's at least one kid who doesn't know how many months there are in a year. There's 36 total months. So we're going to take our $33,553.90, and we're just going to divide it by 36, and this is going to be our monthly payment. So let's see what it is. There you go, $932.05. Now, very few people take a 3-year car loan because the monthly payment's higher. And you're probably going to turn me off right here, but what if I had changed this to, oh, wait a second. Oh, Milbrath. It was a 5-year loan, wasn't it? Ooh. Bad Milbrath. I need to do 5 times 12, which is 60. I'm sure somebody like Milbrath, you made a mistake. Just watch the video. Let's do that again. There we go. 559.23. Now, what you run into a lot lately is because cars have gotten so blasted expensive. A lot of people are actually taking 7-year loans. And the reason they take a 7-year loan is because the monthly payment will be lower. So if I'd have done a 7-year loan, I want you to notice you're going to pay $12,700 in interest, but there's 84 months in 7 years. Your payment's $110 cheaper per month. So, I mean, this happens a lot because you need something, but you can't afford a price where you pay less in interest. So you pay more in interest, but you're also paying for the vehicle 2 more full years. And you have to pay a lot more cash out. So, use that example to guide you in real life. Do your best. All right, 2021. Oh, no, I don't know why that's in there. Okay, so that's it. That is the end of this thing. All right, there's your twin. I hope you guys do well tomorrow. I sincerely do. It's easy to grade good tests. It is. It's hard to grade the bad ones. I literally, I pick up your test and I'm rooting for you. And sometimes I'm pretty happy. Sometimes I'm surprised, but it just stinks when I have to give you a bad grade. It really does. So please try hard.